Well, hello everybody. It's been a number of months, so it's time for another video. Today we're going to kind of cover this Keithley 224 programmable current source. I've needed one of these over the years. I've kind of gotten by with just building quick and dirty little current sources, but in the end I wanted something that was programmable and something a bit more flexible. So I purchased this. I've done some very basic bench testing on it just to confirm that it was working, and I can confirm that it does work. So today we're going to dive into this thing, and I'll kind of show you how to operate this thing and what we can do with it. Okay, to start, we have of course our data entry pad and sub keys here. We have our display function keys here. We have our triggering control keys over here, and we have our display modifiers here. This key here turns the output on and off on the back. And we have, of course, GPIB indicators here. And we have the display here, of course, that provides 4.5 digits of resolution. So we can display, current and our compliance voltages. And of course we have the rear view of the instrument here. We have our 2-lug tri-X output connector. We have binding posts here that are used to monitor your compliance voltage. This is so you don't introduce any extra leakage or load down the circuit under test. Of course we have the GPIB connector here, address select switches here, a TTL compatible 4-line I/O bus, and the trigger in and out BNC connectors. Alrighty, we're all set up, ready to go. So let's do some basic tests here. Turn the unit on, goes through its self-test. Firmware, HPIB address. Okay, so now this is how the instrument comes up in default. So now, first thing I want to check is what the compliance voltage is. It should be 3 volts. So you press the V limit, and it's at 3 volts. Now you can enter anything you want here from 1 to 105 volts. So if we wanted to enter 50 volts, go 50, enter, and there's your compliance voltage at 50. But we're going to stick with 3 volts. Next, we're going to enter our static current level, and we're going to go with 50 microamps to start. So now, all we have to do is turn the output on, and the multimeter here is showing 50 microamps. Now you can either go in here and press this digit button and change these on the fly like this. So we can go increment up to 55, and we're showing 55 microamps. Or you can decrease it, and you can also change the resolution that you want to decrease it in, and so forth. But anyway, that's how you do that. And so if you want to set this thing up to, say, characterize a semiconductor like a diode, you can set this thing up to ramp current limits. You can start using this button here. You can set a lower current level to start with, and then ramp it up to a higher current level, and then chart the results on a plotter or chart recorder. Okay, next little demonstration here. We are going to set up this current source to sweep between 50 and 100 microamps. So the first thing we need to do is that we need to set our current limits. So the high limit we're going to set for 100 microamps. The lower limit we will set for 50 microamps. Now we're going to check our time interval. It is at 50 milliseconds. So this is the how often it will step. Our compliance voltage is still 3 volts. So now we have to go to the source and we have to set this to our low limit of 50 microamps. Now we can go into, let's see, we'll turn the output on so we can see it on the meter. And then we use the digit position button here to change the step size that we want to step in. And we will go there and then we'll tell it to incrementally step upwards. So now it's going to step upwards at 50 millisecond time intervals, 100 microamps, or nanoamps, excuse me, all the way up to 100 microamps. Once it gets there, it will show an error that it reached the end. And now we can do the same thing again. Press auto and we can step downwards till it reaches 50 microamps and it will stop. So you could use this method to, jeez. Oh, I hate it when that do that. To characterize a diode or LED or whatever. But yeah, this is kind of an interesting instrument. I'm probably not going to get a whole lot of use out of this. I will use it to, I basically actually bought this to calibrate another multimeter I'd bought, Simpson 230. You'd use this to set the full deflection scale on the meter. The meter movement itself is a 50 microamp movement. So at 50 microamps, it should be full scale. So this was one of the reasons why I bought this. The other is just basically also check the accuracy of my my multimeters in the current domain. So yeah, it's an interesting instrument. I really haven't. Maybe later on I'll do a few more interesting projects with it, but right now it's just to kind of demonstrate how the thing works and how to set it to do a couple of things. So as far as that goes, that's about all I got for you guys. I'll get some more stuff going on later. Been pretty busy. Haven't had a whole lot of time to do anything. So hopefully we can change that here soon. So anyway, guys, thanks for watching, and we'll catch you next time around.